Hello, welcome to the second video in the chapter 1.3 video lecture series. All right, the last thing we discussed was looking at coffee consumption, lung cancer, and all the confounding variables that could be in there. All right, so I've got 4 scenarios here. For each of the following relationships, identify a possible confounding variable. First one, more ice cream sales have been linked to more deaths by drowning. The total amount of beef consumed and the total amount of pork consumed worldwide are closely related over the past 100 years. People who own a yacht are more likely to buy a sports car, and people with short hair tend to be taller. All right, on the discussion for this chapter, I'm going to ask you to come up with confounding variables. What do you think could be confounding variables for these 4 scenarios? And then once you submit, I encourage you to look over your small group members. So for this week's discussion, I'm going to put you in small groups of 4 to 8. So it's not the entire class. Answer a bunch of questions. Once you're done submitting, you'll get to look at everyone else's responses and see. I'm sure for some of these, a lot of you are going to think the same thing. But for some of these, you might think of something very different than your classmates. So it'll be interesting to see. All right, as another example, the president of a large university, this study was done in 2011, published 2011. The president of a large university announced that the school would be switching to all single-sex dorms. He cites studies stating that in universities that offer both same-sex and co-ed housing, so dorms that have all male or all female, and dorms that mix up, co-ed, students in co-ed dorms report hooking up for casual sex more often. Can we conclude from these studies that this new policy will reduce the number of student hookups, the policy of only having same-sex dorms? I'm hoping your skepticism meter is up, and that is a no. If we could think of some confounding variables here, I listed a couple. The desire for casual sex is not going to change, and or choosing to live in a co-ed dorm. So I want to go over that just for a couple seconds or so. If you think about people self-select into dorms, people pick whether they want to be in the same-sex dorm or in co-ed dorms. So it's the counter-argument to this president's decision is that it's not the fact that we have co-ed dorms, it's just the fact that students that select to go into co-ed dorms are more likely to hook up for casual sex more often. And not giving that option is not going to change that fact necessarily. Okay, so that leads me to getting to experiment versus observational studies. And an observational study is a study in which the researcher does not actively control the value of any variable, but simply observes the values as they naturally exist. So any type of survey you give to people to collect information is observational. By itself, observational studies are not bad. They give us very good information. I don't want you to think we should stop doing observational studies, but they have some drawbacks, as we'll go over shortly. And to compare that, an experiment is a study in which the researcher actively controls one or more of the explanatory variables. All right, so for observational studies, the drawbacks are there are almost always confounding variables when doing an observational study. Observational studies can almost never be used to establish causation. This is huge. Let me say this a little bit louder. Observational studies can almost never be used to establish causation. I was being literal there. And, oh, that's right, I forgot to add these sound effects. Oh, explosions. Wow. Observational studies can almost never be used to establish causation. And when I go by causation, again, correlation is just another way of saying an association. It's not necessarily causation. I put a hyperlink on here. I think he was a statistics graduate student, started putting together what are called these spurious correlations. Now a ridiculous book. I need to order that book. So looking at U.S. spending on science, space, and technology, is very strongly correlated or associated with suicides by hanging, strangulation, and suffocation. And I hope you think that those are not related at all, except that they are just mathematically. Here's one of my favorites. Number of people who drown by falling into a pool, it correlates strongly with the number of films Nicolas Cage appears in a particular year, as you can see from this graphic. Maybe the people that watch Nicolas Cage films jump into a pool. No, let's just keep going. The per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. It's kind of nuts to think that there's hundreds of deaths of that happening. Maybe if people eat too much cheese and then go to bed, there's an issue there. But probably not. Divorce rate in Maine, per capita consumption of margarine is strongly correlated. Age of Miss America correlates strongly with murders by steam, hot vapors, and hot objects. Again, here, okay, this makes more sense. It's a small amount of murders each year, but there's some correlation there. Total revenue generated by arcades, computer science doctorate awarded in the US. Okay, maybe you could find some connections there besides just the math. Find people who drowned after falling out of a fishing boat correlate strongly with marriage rates in Kentucky. Okay, there's a lot more on here. I'm going to go back to the slides, but I wanted to show you a couple of these just to go back to that idea of correlation is not the same thing as causation. Or you could say in our class, association is not the same thing as causation. Association and correlation is just mathematics. You could mathematically show two things are connected. It could be purely coincidental, or there could be a bunch of crazy confounding variables. All right, and Gould, he's written some statistics textbooks. He's a researcher. Love this quote. The invalid assumption that correlation implies causation is probably among the 2 or 3 most serious and common errors of human reasoning. He's probably correct. Okay, so one way to try to avoid those confounding variables we talked about in the last video is randomly assign values of the explanatory variable. So in a randomized experiment, the explanatory variable for each unit is determined randomly before the response variable is measured. And the different levels of the explanatory variable are known as treatments. The idea is to randomly divide the units into groups and randomly assign a different treatment to each group. In general, we want to have at least 2 groups, a control group, which does not get the treatment, and then the treatment group. Now there could be more than one, different levels of treatment. Maybe you want to check to see, how caffeine consumption affects someone's memory. And you could randomly divide a sample into 4 groups. One group gets, decaf coffee, and they don't realize it. Another group gets a regular cup of coffee. And then the last 2 groups get, much stronger coffee or coffee with espresso shot, just to see how different rates of caffeine could affect memory. And, maybe give those people a memorization test just to see how the effect is. That'd be one just really quick example of having more than one level of treatment. And if the treatments are randomly assigned, the treatment groups should all look similar. So in my last example, if you had 4 groups with the coffee and memory, you don't want all groups to look about the same, to be about the same size. And that's the idea with that randomness. If you randomly assign, they should look similar. So if you do a randomized experiment, where there's a control group and then a treatment group, and the experiment yields a significant association between the 2 variables you're testing, say caffeine consumption and memory, then we could establish causation from the explanatory variable to the response variable. So randomized experiments are very powerful because we can infer causality. Remember, observational studies generally cannot infer causality, but randomized experiments, if done well, can allow us to infer causality. Okay, so let's look at 2 studies that are looking at exercise and the brain. study found that elderly people who walked at least a mile a day had significantly higher brain volume, that's gray matter related to reasoning, and significantly lower rates of Alzheimer's and dementia compared to those who walked less. All right, and there's an article, linked down here, states walking about a mile a day can increase the size of your gray matter and greatly decrease the chance of developing Alzheimer's disease or dementia in older adults, a new study suggests. All right, is this article lying? Or I should say, is this conclusion valid? I would say no. Okay, what's wrong here? This study is purely observational. They just observed elder people, those that walked more and those that walked less. And then the article summarizes it as a causal statement. The wording of this implies a causal association between exercise and Alzheimer's dementia rates. But this is an observational study. So we could say there's an association, there's a connection, there's a correlation between exercise and Alzheimer's rates, but we cannot say there's a causal association. So how could we, if you think this is true, and this is kind of how science works, okay, we think it might be true that exercise could lower dementia and Alzheimer's rates. How could we design an experiment to test this? Well, ideally, you would take a large sample of elderly people and then randomly assign. One group is forced, or they have to walk at least a mile a day, and then there has to be a control group that is forced or not allowed to walk very much. Hopefully you can see there's some ethical issues with this. It's not ethical to force anyone, elderly or not, to walk or not walk. So in some ways, a direct randomized experiment might not be possible, at least in the United States, where we have individual rights. So we're going to go to mice. The study was done. A sample of mice were divided randomly into two groups. One group was given access to exercise wheel, and the other group was kept sedentary. I don't think about that too much. That might be a little sad for poor little mice, but they weren't allowed to exercise very much. From this study, the brains of mice and rats that were allowed to run on wheels pulsed with vigorous newly born neurons, and those animals then breezed through the mazes and other tests of rodent IQ. And this is compared to the sedentary mice. So the sedentary mice did worse. They didn't have as many neurons, and they didn't do the mazes and IQ tests as well as the rats that exercised. Is this evidence that exercise causes an increase in brain activity and IQ, at least in mice? Here we're going to say yes, because there's a randomized experiment. We could yield causations because there is a treatment group. The treatment group is the set of mice that were given an exercise wheel, and the control group was kept sedentary. And there was a measurable difference in the outcome. So because there was a randomized experiment that randomized the treatment variable, we could imply causality. Again, at least in mice. All right, and I'm going to stop this video. We're going to come back to this example on the next video.